Hi, and welcome to Pitch and Throttle Curves 101. So what is all this mumbo jumbo you always hear about? What is normal? What's idle one? What's throttle hold? What's a curve? Well, that's what I'm going to try to explain in this video. But before I do, I want to touch on endpoints real quick and digress and explain how a curve works and what the endpoints do. Some people tend to get them confused sometimes. If you remember throughout my other build videos where we set up CCPM and we set up our servo throws and all that, I basically had you reset the radio so that your endpoints were 100 and 100 on each side of the stick. So when you move the stick to the right, it's 100%, stick to the left, it's 100%. And I wanted you to do that so we could get everything mechanical rather than have the radio programmed weird or have different endpoints that could mess us up mechanically. Having it equal on one side, 100 to 100, allowed us to set everything up mechanically. In part of this conversation, we're going to talk about how we change the radio programming to actually do something different mechanically that we need to do. So you understand endpoints, on a lot of radios you can reduce the endpoints, and that reduces the total servo throw. If I reduce the endpoints to 50 on each, then my servo is only going to move 50% of what the stick is. Meaning that when I move the stick full to the right, I'm only going to move the servo 50% of that movement. If I move it full to the left, the other way. Same kind of thing. Some radios will allow you to go beyond 100%. So when I move the stick all the way to the right, the servo will move a ton way out over here. So endpoints basically limit your total servo throw. Now, I don't want to get too complex here because mixing can overdrive your endpoints, but for single surface controls, look at your endpoint as this is telling the radio no matter what I do, this is as far as the servo will throw. CCPM's a little different because mixing overdrives it, but bottom line, that's what endpoints are. So we wanted everything equal across all channels so we get mechanically set up. Now, so how do curves work within this? Well, pitch and throttle curves work within your endpoints. They don't extend your endpoints, they work within your endpoints. So what exactly is a curve? Well, for getting endpoints now, let's go into curves. What a curve is, when we reset your radio, we made a linear curve. Now, most radios have 5-point pitch curves. What are 5-point pitch curves? Well, a 5-point pitch curve is exactly this. When I'm at low stick, I'm at this point in the pitch curve. When I'm at halfway between low and half stick, I'm at point 2 of the pitch curve. When I'm at half stick, I'm at point 3 of the pitch curve. When I'm at 3/4 stick, I'm at between halfway and the end at point 4 of the pitch curve, and full stick obviously is point 5 of the pitch curve. So how does the curve relate to all this? Well, the curve relates to all this because you can change, right now this is called a linear curve, which means as I move the stick from one end to the other, the servo will move linearly. If I move it halfway, the servo moves halfway into its distance. I move it full, it moves full into its distance. But a curve allows you to change that. For instance, I could make a curve that looked like this if I wanted to. So what would that do if I made a curve that looked like that? Well, when I move the stick at point 1 to point 2, the servo's barely going to move. When I move to point 3, the servo's still barely going to move. When I move to point 4, okay, it's starting to move. And when I move from point 4 to point 5, it's really going to truck. Now, this curve still gives me the same amount of throw between my endpoints. I'm still going to get the same amount of throw. But what it did is it flattened it out for the first 4 points of the stick, and then up here it really trucks. So you'd actually watch the servo do something like this as I moved the stick. It would barely move, barely move, barely move, barely move. And then as I got up here, it would just whoop all the way over. So that's kind of what a curve does. Now, there's interesting things you can do with curves. And I'm not going to get into expo in this video, but suppose we had a curve that looked like this. It came up, went flat in the middle, and then came up again. Now, what that kind of curve would do is similar to what I explained here. At the end of the stick, it would move the servo a lot. But in the middle here, right in the middle points of the stick, the servo would hardly move. Well, if you wanted to put expo in a radio on aileron and you wanted it to be less sensitive in the center, you would actually set a curve very similar to this. That way in the center, the servo hardly moves, but when you want to move it, you move the stick way over. In the center, it would hardly move it way over, and the servo would really truck. That would be what's called as exponential control, and you can soften your controls in the middle. But that's not what this video is about. It's really about throttle and pitch curves. But I wanted you to understand that a curve works within the endpoints. Now, the only time it gets interesting, where it may be similar to setting an endpoint, would be if I brought point 1 up the curve. Let's say I made a curve that was, say about 30, and another one at about 35, and another one at about 40, so that I had a curve that brought these endpoints up. If I bring this 0.5 down or this 0.1 up, then that's when the curve acts similar to adjusting your endpoints. In other words, my starting position of low stick is no longer 0. It's no longer the end of the range, or my 0.5 is no longer 100. It's no longer going all the way to the end of the endpoint. So I can actually change these end points to make it act like it is doing an endpoint adjustment. So when I start out at low stick here, because I'm up at 30, actually my servo, if it was 0 down here, my servo would be here. But now that I've set it to 30, the servo's 30% into the movement already, and I can't go any lower on my stick because I've set it that way. So that's something you need to understand. The middle points can change how the servo moves within the two end curve positions. The two end curve positions can actually change the starting point of where it is within the end points. That's why I wanted to touch on end points, and that's why I wanted to explain curves a little bit. You'll understand this more when we go to set up a normal curve, and in normal mode we don't want 11 degrees of pitch when we're first starting out. We want, in normal mode, probably about 3, 2, or if you're a beginner, maybe 1. So you would bring this first point up in the curve, so its starting point would not be the same as if it would be 0, which would be the full servo direction. So anyway, that's a little bit about curves and how they work within the radio. Now I'm going to go a little bit into the different types of curves and what they're used for. Okay, I do want to touch a little bit on radio differences and how curves are displayed. On higher end radios, a lot of higher end radios will actually show you, similar to what I was drawing on paper, it will show you the curve. And if I move the stick, you can actually see a little arrow at the bottom down here move along the curve to show you what stick position references what curve. Now, this is a 9Z. It has a 14-point curve, so you can really finely play with the curves. Other radios may not show you a graph. Other radios, what they might do is just simply have the points setting in the radio. So you have to understand that 0.5 is going to be at a full stick position. Now, whenever we're messing with throttle and pitch curves, we're always talking about the throttle stick here. Throttle and pitch curves is always related to this stick. So 0.5 is going to be your point out here on your end, and obviously 0.1 is going to be your lower stick position. So 0.1 usually almost always is low stick on the throttle, and 0.5 is almost always high stick on the throttle. Okay? So I just wanted to touch a little bit on how different radios may display them. Okay, so getting back to curves, if you recall again, I'm going to say this again, when I was having you set up your helicopter before and we reset your radio, we basically reset it and made sure we had a linear curve. 0.1 was 0, 0.2, 25, 50, 75, 100. Okay? And the reason we did that is we wanted to get the bird mechanically set up to be able to do 3D. What that means is with this linear curve, with the stick all the way back, we can get minus 11 pitch, and the stick all the way up, we can get plus 11 pitch. And of course, at center stick, we had 0 pitch. We wanted the radio to be set like this so we could set up mechanically the bird to do 3D. But that's all great, and as a matter of fact, you will not change this curve for what's called as idle 1. So what is idle 1? Well, idle 1 is your stunt mode. It will allow you to fly around inverted, fly around right side up, do flips, that kind of thing. Why? Because when you're upside down, we need to be in the minus pitch range. So basically, everything you do when you're upside down between center stick and low stick is giving you negative pitch. Everything, if you're flying around right side up, everything you do from center stick above gives you positive pitch. And of course, center stick is 0, meaning no pitch. So that's the way you set up for 3D. It's when you're upside down to give more pitch and climb up into the air, giving negative pitch, you'll be pulling back on the stick. And if you're right side up to go up in the air, obviously you give positive pitch. 0 pitch basically is there's no lift from the blades whatsoever. So we wanted to do that because we wanted to get set up for 3D. So basically you will leave in your radio your idle up 1 pitch curve to a linear fashion and leaving it at plus 11, minus 11 because we had the bird mechanically set up to do that way. So our idle 1, which is our stunt mode, we will not touch that curve. But in normal mode, we do want to touch that curve. Now remember I talked about this. If we set the first point, which was at 0 in the curves, if we leave that there, that means that when we're starting out and our throttle's at low, and I'll get into throttle curves in a little bit, but our throttle's at low and we start spooling up the motor, we're sitting here spooled up and we've got all this negative sitting on the ground, the bird's sitting on the ground, it's got negative pitch, it's sucking dirt up like crazy, forcing the heli down onto the ground because of the negative pitch, which we kind of don't want to do. Now I do know some people that leave a linear curve even in normal mode, but I don't recommend doing so, especially for a beginner. What we want to do is we want to go in and change our points in our curve for normal mode so that basically point 1 gives us anywhere from minus 3 to minus 1. If you're a real newbie and you're scared to throw the helicopter down into the ground, and what I mean by that is you're learning. So you're hovering up here around 3/4 stick, which basically you will be because we've got your helicopter set up for 3D to begin with. So you're idling around here and you panic and you want to land real quick. If you pulled back fast and we left that all the way to minus 11, you'd throw minus 11 into the bird and that thing would come down so fast it would surprise the heck out of you. So newbies might want to set for maybe even minus 1. Now you do need a little bit of negative in your helicopter to be able, if it's windy, to be able to actually bring the helicopter down. So again, somewhere between minus 2, minus 3. So how do I do that? Well, I'm going to go into my radio and I'm going to take my helicopter and I'm going to put my pitch gauge on my helicopter and I'm going to go into the normal throttle curve. Normal throttle curve. Matter of fact, I'm not going to show it on the radio. I'm going to go into my normal throttle curve and I'm going to set point 1 and I'm going to keep increasing the number. Right now it's 0. I'm going to keep increasing that number until my pitch gauge reads about anywhere between minus 3 and minus 1 degrees. Okay, so you'll put a pitch gauge on the helicopter, you'll turn it on, and you'll go ahead and start increasing point 1 until you get anywhere between minus 3 to minus 1. Again, if you're a real newbie and you're just beginning, you might want to go for minus 1. So now, what do we want to do with point 2? Well, if I don't adjust point 2, what my curve is going to look like is basically going to look like this. Let me draw it real quick. I brought point 1 up. Okay, I never touched point 2, and remember we left that in our linear curve. We left point 2 at 25. Well, if I bring point 1 up and let's say it's about 40, then what's going to happen is my curve is going to look like this. If I don't touch point 2, it's going to be here, and then it's going to come down to here, and then it's going to go up linearly again back up. And I don't want that. I don't want this drop here. I want to try and keep this line as close to linear as I can, okay? So what you'll want to do is bring point 1 up till you get about minus 2, minus 3, then bring point 2 up so it's halfway between point 3. Now we're going to leave point 3, point 4, and point 5 at 50, 75, 100. Why do we want to do that? Well, that's interesting. All we're trying to do here is bring up our negative pitch, so we only have, this would be, minus 3, let's say. This point would bring you to about minus 1 or maybe close to 0, and this would bring you to 0 pitch. Remember, center stick, 0 pitch. Well, the reason we don't want to change these is because in our idle up condition, when we go from normal to idle up, we don't want a pitch change. And by the way, when I'm talking about that, you're not sitting on the ground and flipping the switch. You're getting into the hover in normal. Okay, so now remember, we're hovering. If this is zero pitch, we're probably hovering right around here in the stick. Okay, this is probably going to be around 5-6 degrees. So we're probably hovering out here somewhere. And if we're hovering past 0.3 when we flip the switch, and our normal curve from 0.3 to 0.4 to 0.5 is 50, 75, 100, 50, 75, 100, when we flip from normal to idle up, we won't have a pitch change and the heli won't jump on us. If we flip down here, obviously we will definitely have a pitch change. So you don't want to flip your idle from normal to idle up after you've set this normal curve unless you're into the hover. When you're in the hover, you know you're going to be above half stick. Because remember, I'm going to say it again, half stick is zero pitch. You ain't hovering here. You're going to be up here about 3/4 stick somewhere, hovering around here. So this is why we want 0.3, 0.4, 0.5, and 0.3, 0.4, 0.5 between these two modes to match, so we don't get a pitch change when we switch from normal to idle up. Okay? So what you're going to do in your heli again is you're going to bring up 0.1 till you get about -2, -1 if you're a real newbie, -3 if you like, and put 0.2 in between. If this is 50 and you wound up at, say, 40 here, then this would be 45. You want to try and get this as linear as possible. Don't leave that point sitting down here somewhere or you're really going to have trouble. Okay? So that's setting up a normal pitch curve. All right, so now we've got our pitch curves. We've got our normal pitch curve. We've got our idle up pitch curve, basically the same as we set to begin with. We never changed the idle up pitch curve. Now I'm going to go into throttle curves and what's that's all about. Okay, so what's a throttle curve and why do we need them? Well, the reason we need them is not always does a motor provide power in a linear fashion, okay? And especially on a T-Rex electric. A T-Rex electric, the power band is way up here in a curve. Way up here in a curve. And I'll talk about that when we talk about an idle one throttle curve and why it's set so high, and you'll see in a minute. But let's say we've now got our pitch curve in this fashion, and when we're hovering around here, well, if we had a linear throttle curve, such as we did, let's say for some reason, and right now our radio is still set for a linear throttle curve, let's say for some reason we're hovering around here and our motor RPM's too low. So in other words, we've got 6 degrees of pitch, but our motor RPM is low for some reason. Well, maybe the motor's output again is, like I said, the motor needs more of a curve that looks like this, in which in fact the T-Rex does. So if we're hovering around here, sorry, I drew that wrong. Say it needs more like that. So if we're hovering around here and our RPM is low on our motor, that means we need to change our throttle curve so that the power matches the amount of pitch we have in the helicopter. So when you first bring up your bird and you're going to play with throttle curves, I'm going to give some recommendations, by the way. And you're going to play with throttle curves. If you're hovering and you've got this really low head RPM and the helicopter's actually oscillating in the hover, well, it's because we've already got our pitch curve. We've set it based on the pitch of the blades. Remember, I said 0.2, 0.3, put it in between. We know this brings us up to 11. We're not going to mess with the pitch curves anymore. We've got them. Now we need to match the power band of the motor to the amount of pitch we need in order to hover and in order to fly around. Now, obviously, way out here at 11 degrees pitch, we want full power of that motor. So chances are the throttle curve will remain 100 on this particular point. But somewhere in between here, we may need, matter of fact, we are going to need a curve that is not going to be linear. Even on nitro helis, I've very rarely had, for a normal mode pitch curve, as well, a linear throttle curve. There's always seems to be, the power band of motors always seems to be up here somewhere. So, and pardon the white paper, I ran out of yellow. So, what we want to do now is we want to start matching our throttle to our pitch. So, it's definitely not going to be linear, and I'm just going to throw up some numbers at this point now to get you started. But basically, you're going to wind up with a curve that ramps up sharply to get into the power band of the motor, and then will flatten out. And that's the idea. Okay, so the numbers I'm going to tell you to start out with for a normal throttle curve is we're going to go set 0.1 to 0, because we need 0 because when we land, we want to be able to turn the throttle off. So that stays 0. However, we're going to bring the first point, point 2 here, up to 50. And then we're going to go 80, 90, 100. So we're going to wind up with a throttle curve. I just use another piece of paper here. So we're going to wind up with a throttle curve that looks something like this. It's going to ramp up real quick. Okay, so we've got 0, and then point 2, we've got 50, and then 80, 90, 100. Okay, and that's going to be your power band, because we need the motor if we want some good RPM and some good power when we're hovering in our pitch. Now remember, you can almost overlay these two curves together. Let me go wide again. You can almost overlay these two curves together. As you move the throttle stick, you're going to be going through two curves here. One is the pitch curve, so the blade pitch will change as you move from low stick to high stick, and the other one's the throttle curve, which will move as you go from low stick to high stick. Okay, so there's two curves we're dealing with here, pitch and throttle. And for the T-Rex electric, your throttle curve is going to look something like this. So again, my recommendation to start out, and now I'll zoom in again, my recommendation to start out for a normal throttle curve is going to be 0 on point 1, 50 on point 2, 80 on point 3, 90 on point 4, 100 on point 5. Now, you'll have to tweak those to your liking. Obviously, you can drop this 50 and 80, etc., to reduce head speed, or you can bring them up. You could have 0, 80, 90, 95, 100 if you wanted to, if you really wanted a cooking head RPM there. So that's basically what's happening. This curve is going to drive the RPM of the motor, while this curve, the pitch curve, drives the pitch of the blades. So that's how they relate to each other. I hope that was clear. So, bottom line, that's my recommendation for normal pitch curve. Now we'll talk about idle up. So, what is an idle up pitch curve? Well, this is going to look freaky to some people who never have seen it or understood it before. But in an idle up condition, think about it here. We're now in idle up. We want to fly around upside down. And remember what I told you. We want to fly around upside down. So every time I pull back on the stick, I'm giving negative pitch. Well, we also don't want, if we had a regular linear curve for throttle, we don't want the throttle to go to 0. Heck no. We're upside down. We want to climb up in the air. So we want to give negative pitch. But we also want the engine to come up. Remember, you need more engine the more pitch you have. Whether you're upside down or right side up, a plus 11 pitch, right side up is full pitch. You want full power out of the motor at that point. Well, if you're upside down, you're between center stick and low stick now in idle up, and you go into negative pitch. You also want power out of the engine. So at full 11, it's just like if you were right side up. You want to climb up. You want as much power as you can get because you're driving in as much pitch. So what is a throttle? I hope that made sense. What does a throttle curve look like in idle up? Well, basically, we're going to set point 1 to full throttle, because that equates to minus 11 pitch. So when you're at full negative pitch and you're upside down, you're climbing up out of the sky. We also want point 5 to be, and remember this is related to plus 11 pitch, we want point 5 to be full throttle. So these two endpoints, we're going to set at 100 for throttle curve in idle 1. That way, when we're upside down, we get the same performance out from pitch relation and performance from pitch relation, whether right side up. So upside down, right side up. Now, the next thing is point 3. Well, where's point 3? Well, if we remember on the pitch curve, point 3 is 0 pitch on the pitch curve. Well, obviously, you may not want 100% throttle at point 3, because what will happen is with no load on the blades and no pitch in the blades, the head's going to be able to spin faster, because if you leave this at point 3 at 100, you're going to be having some smoking RPMs here. There's no load because there's no pitch. So usually a idle up pitch curve looks like a V in relation. And then basically what you do is for point 2 and point 4 is make them linear between point 1 and point 3, try and get it in between, and point 5 and point 3, try and get it in between. For sure we want these two to match, so when we're right side up, halfway between full and 0 is the same amount of pitch and same amount of power as it is halfway between middle, and low when we're inverted. So we want 0.2 and 0.4 to match. But what exactly they are will depend on how much RPM you want to do. So you will set these for 100, and you'll play around with these until at zero pitch your head isn't smoking. You want to start lowering zero pitch or raising it to try and get the head RPM to remain consistent between having full pitch, full throttle, and zero pitch and whatever throttle. Okay, now I'm going to give some recommendations on this for the T-Rex as well. So whatever you find 0.3 at zero pitch, and your head RPM looks like it's staying consistent between here and here, then just go ahead and put this point in between somewhere. You could actually find that you know, if this is 6 degrees here and this is 6 degrees negative and this is 6 degrees positive, you could actually find instead of a V, this could be a U-shaped curve. It all depends. But on a T-Rex, I'm going to give you a curve that works pretty good for me. It gives me about 28 to 3,000 RPM, and you can reduce it from there. Okay, so here are my recommendations. Again, normal throttle curve 0, 50, 80, 90, 100. For idle 1, throttle curve 100, 95, 90, 95, 100. Now remember, this is 0.1, 0.2, 0.3, 0.4, 0.5. If you notice, 0.2 and 0.4 match. Again, I talked about that. So when you're upside down, halfway between center stick and end stick, the performance of the motor is the same as if you're right side up, halfway between center stick and full throttle. Okay. Now you'll notice that as I said, when we switch to idle up, never switch to idle up between low stick and mid stick. You want to be in the hover when you switch to idle up. Now, but you'll notice here with these two curves that you're going to get an increase in RPM because the motor now, you know, if you're hovering right around here, the motor's somewhere between 80 and 90, versus in idle up, it's somewhere between 90 and 95. That's normally the way most people set up a heli. You'll see them when they switch into idle up, and the engine RPM will increase. But if you want to make a match because you don't like the engine to increase like that, and possibly make the heli jump. Remember, we're not changing pitch here. All that's going to happen is the head RPM is going to go up, but it does produce more lift. You can go ahead, if you want, and set your normal to match 0.3, 0.4, 0.5 for the throttle as well, but you don't have to. I usually set up like this. Okay, so for normal pitch curve, now, even though I'm giving this a recommendation, you really need to put a pitch gauge on the bird and set for the amount of negative that this point will give you. If you're a total newbie and you're afraid to drive the heli into the ground with too much negative, maybe -1 on your pitch gauge. So this number and this number will vary depending on how much pitch, negative pitch you want in normal mode. Okay, but this is what I've found usually setting up a heli. This gives me about -3. That may be too much for some new people, but that's about -3. And obviously 45 is probably about -1.5, and then this is zero pitch. Okay, so these numbers may vary from my recommendation, but these will stay the same as they will for idle up. For idle up 1 pitch, it's always going to be linear because we set the bird up that way mechanically. 0, 25, 50, 75, 100. We won't change idle up. And again, these last points, so you don't get a pitch change when switching into idle up, will remain the same because you'll be hovering when you switch. Okay? So that is Curves 101. I hope it was helpful to you, and enjoy.